Hi, grade 11s. Today we're going to look at a problem that you guys were assigned for homework, and I just wanted to give you guys a more in-depth look at this question because some might find it a bit challenging. And it's talking about cost, price, and profit, and a company is selling electronics. So it says this electronics store sells an average of 60 systems a month with an average of $800 more than the cost price. So they're marking it up $800 above what they paid. And they know that for every $20 they increase the price, they're going to sell one fewer system. So they want to know, if they keep increasing the price, what will maximize out their profit? So how many times are they allowed to go up by $20 before they start losing sales enough to affect their profitability? So the first thing I want to do is set up a profit function. So I have P of X. And what I'm going to do is I'm going to create a part of this for price. So I come over here, and what is really about price? Well, it's $800, and I'm going to increase the price $20 for every time. So I'm looking at 800 plus 20x. If I increase it once, it's 20. If I increase it 100 times, it would be 20 times 100. So, and we'll go from there. The second part of this question, besides price, is I need to figure out their sales, because we know that as we put the price up, the sales will go down. So for our sales, they're selling 60 a month, but every time they put the price up once, for every $20 increase, it goes down by 1. So we can write that as 60 minus x. All right, so now we've got our profit function. We need to take this and multiply it out. So we just distributed this, and we end up with P of x is equal to negative 20x squared minus 800x plus 1200x plus 4800. And then I can simplify this to negative 20x squared plus 400x plus 4800. I've done this because my intention is to solve this problem by going directly to the vertex by way of partial factoring. So what I'm going to do now is I'm going to partial factor this quadratic. So what I do is and that's going to give me the x coordinate of the vertex. So for P of x, I'm going to actually divide each of the first two terms here by x and negative 20. So I'm going to factor out negative 20x. And that's going to give me negative 20x and then bracket x minus 20. What this gives me is two coordinates that are not the x-intercepts, but are two coordinates that are equal in height or at the same point of the parabola. The 4800, or the y-intercept, hasn't really changed, so I'm just going to stick that out at the end. I now find the zeros. What will make this a 0? What will make this a 0? So I end up with 0, because negative 20 times 0 is 0, and 20. So 20 minus 20 is 0. So those are the zeros of this particular quadratic at this point. I then find the midpoint of these, because the midpoint is what I'm going to use. The midpoint here is 10. That means my axis of symmetry, or the x-coordinate of the vertex, is 10. In this question, that's really all I need to know, because I know that I'm going to have my maximum at this point. I can then take this point, and because I'm trying to maximize profit, I can just plug it in here for the first value of x and go price 800 plus 20x. I know that I'm going to have to increase it 10 times. So 800 plus 20 times 10 is 800 plus 200, or $1,000. So what amount of cost price will maximize profit? $1,000. That's not how much they make, but that's how much they make off of each one. It's a bit confusing. If you're still not sure about partial factoring, I suggest you go back and watch the video on partial factoring. Any questions? We'll be doing more practice tomorrow in class.